Good evening and welcome to the fourth recording of the Who's Your Hacker Con webinar series recorded April 23rd, 2020. My name is Scott Lyons and I'm joined by somebody that you may or may not know, Amelie Koran. She is going to be giving us a presentation on data analytics and metrics for the win. Then after, there's going to be some light question and answers, you know how we do. So join us as we try to figure out who's your hacker. Welcome to the Who's Your Hacker Con webinar series. We are putting on weekly webinars leading up to the live event scheduled for September 25th to the 27th, 2020. For more details on upcoming speakers, please check out www.who'syourhacker.com. Today's episode is brought to you by Red Lion. Breaches happen. Red Lion is the only risk management company which is MRR and MSP friendly. Compliance and security connected, Red Lion. Visit redlion.io for more information. Welcome. So let's see here, a little upfront house cleaning as we start, right? As a reminder, this webinar series will be held every Thursday night till this pandemic nightmare crap is over with. The link for the next episode can be found at who'syourhacker.com/webinars-free-CPES, or just go to the website and click webinar free CPEs. Also, you can find this plus other episodes on the Who's Your Hacker website, irongeek.com, and on YouTube. Now, let's get into what we've got. Tonight I have the esteemed pleasure of introducing you to Amelie Koran. Amelie is an adept senior technology leader with broad experience in both public and private sectors across a range of business. Over the past 20 years, a lot of progressive hands-on experience in advanced technologies and cybersecurity practices. Amelie's developed tactical and strategic execution goals for multiple organizations. She has also led teams of over 100 staff to deliver these solutions across multiple product and service delivery lines, utilizing agile framework in a DevSecOps environment. So, Amelie is currently a Splunk advocate. Amelie, I'm going to turn this over to you. Did I get that right?
Yeah, you did. Actually, senior technology advocate. So we sit within the IT markets group within Splunk. With that, we actually focus on stuff that's actually not precisely security. But I was hired because I do have the security industry background as well as the senior leadership. So it's been interesting. It's been just a couple months, but getting a chance to kind of not only kind of spread the gospel as it would be for my employer, but also kind of introduce them to how to blend security development and operations in this new paradigm we find ourselves in.
So let me ask you a question, just a little bit more on the background. What brought you to Splunk? How did you end up there?
Well, it's one of those cases. I think was it Victor Kayem of the Remington. I liked it so much I bought the company. However, prior to my current role, I was a customer. Either as an independent researcher, I was using Splunk way back when I was doing a lot more on the engineering side, and I would go and kind of play with the free version at home. But then when I went to go work for the U.S. Treasury Department, I was in charge of the CDM program, the Continuous Diagnostics and Mitigation Program. Within that, the architecture required actually Splunk to do some of the data collection and aggregation. So, having that experience over the years, seeing how it's grown, seeing its various uses, traditionally, it's been thought of as a security product, mainly because its inroads into organizations has been through the security group. But now with, there's the broadening of the market, we're seeing it for doing development support. So application performance monitoring, so doing the traces and so forth there. But also on operations, I was an old system administrator. I was using syslog ng and was a WinSyslog and so forth to try to get all this stuff into something that we can consume in our security group, and getting tools that actually make that a lot easier. It was kind of cool to see. So I'm excited to be where I'm at, and it's pretty product agnostic. While I work for Splunk, I talk about best practices. So that's one of the reasons I'm here tonight.
All right. Okay. Well, hey, thank you for joining us. You have a presentation, I hear?
Yes, I do.
All right, well then I'm going to turn it over to you and let's get into it.
All right, cool. So, my presentation for you tonight, people tuning in from the great internet, is instrumenting and sampling for security data. It's kind of a very interesting and broad topic because there's a lot of data you can kind of classify as security. The subtitle is in there is How You Know I Don't Like Fish, and the punchline for that will come at the end, but you'll kind of pick up on it here and there. So, let's see, next slide. Here's forward-looking statements as I work for a publicly traded company. These are generally my own opinions, my own work product, so forth and so on. There's nothing that talks about Splunk strategy or anything like that, so getting that out of the way. So, as Scott mentioned, waiting for the slide to advance, too far. As Scott mentioned, I have my typical who am I slide here. Where I've gotten to be, it's been a long and winding road. As he mentioned before, you may not know me, mainly because I've kind of lurked back in the shadows of the security community. I've just kind of been there mainly as a practitioner. Over the last couple of years, I've managed to kind of work my way from an engineer, a very bad developer, at various places within the public sector and the private sector. I've worked for the likes of the American Chemical Society as my second job out of college. First one was with Xerox, so there I was a user interface designer, so I was focused a lot on how users interact with technology, which was a lot of focus of where I went to school. And then worked my way around, worked for the World Bank. I was there handling their first major security intrusion. Actually partnered up with my old employer, Mandiant, at the time to actually do the incident response. After that, went back to the public sector to go work for the DoD via the Carnegie Mellon Software Engineering Institute, CERT CC. Did some time there. Got to the White House as a policy analyst. Helped start a bunch of things at the White House, including the U.S. Digital Service. Left to go work for Disney, and during that time I got to see my old employer Stan Lee. So any Marvel fans out there, I've got plenty of stories I can usually tell around the bar for that. But the advantage with that is getting multiple industry and vertical experience has actually taught me a lot on there's no one size fits all to security, to operations, and to development. Especially when it comes to technology. I've been out in the business world for 20 plus years, and it's amazing what's changed over that time, and what we've been able to actually do. Now we've got into a lot more with automation. Systems we're building. First it was your on-prem, your mainframes and client server systems. We started using mobile, and eventually that kind of begat the cloud. And with that, it's kind of changed how we both build and architect it, but also, the threat landscape has changed significantly. So to go over what we're talking about today, I have a pretty simple slide deck here since we're just talking about how to instrument your environment for collecting security data, but it's also data, as I mentioned before, that's useful for developers and operations and infrastructure managers. So I kind of think of it as a river or a creek or, wherever you're from, what you want to call it. With that, my dad was a water quality chemist for a number of years with the Army Corps of Engineers. So, my childhood was going out to rivers and creeks and lakes and so forth, and learning how a chemist looks at that environment, what they need to do to instrument it, the kind of samples they take, what kind of data they get back from it, what kind of decisions they can make. So a technology environment is very, very similar to that. While it may not be a river, your river could be, your network pipe. There's a lot of stuff that goes up over that. Commerce, just like a river would carry barges and so forth. The traffic in there, you have your fish, you have people that could be swimming or boating for leisure. But it also ends up carrying a lot of other things, oil spills, garbage, all sorts of things. So, it's a good parallel as a transport layer. But I also want to give some examples, some stuff that people can kind of take home to kind of think about, how they want to view their own environment, whether it be a small startup to, a large enterprise. Some best practices and worst practices. I've seen a lot of good stuff, and I've seen a lot of bad stuff in 20 years. So hopefully, you can all raise a drink to whichever one kind of toots your fancy there. And, with any good talk, I'm going to give you some outcomes and takeaways that, maybe something you do know, something you don't know, something that helps kind of verify some preconceived ideas. So the gist of this is sampling for security data. As somebody who was a security engineer for a long period of time, I was never satisfied with what I got. If I could put another, box on the network that could listen to another thing, if I could get something that sat on the desktop that presented me some more data, kind of the early warning system, get some user behavioral analytics and so forth. It made me a little bit rest easier at night because I kind of had a better idea of what situational awareness is. Again, as I mentioned, for developers and for infrastructure and operations folks, that's just as useful for them. It may not be security data, but it's also useful. And a lot of times it overlaps. So what is instrumenting? Wikipedia's definition is, refers to the measure of the product performance, diagnose errors, and to write trace information. So, anybody who's done any type of logging or has looked in at a system. I mean, I know Amazon offers instrumentation capabilities as a service. Windows instrumentation is one of those things you can just basically turn on and turn off. Apple's been doing that for years with a lot of stuff. So it's available. You just got to know how to go and use it. In relation to information systems, it is those sensors. It could be a software sensor. It could be a hardware sensor. I know, I'm recording this on a phone. In fact, actually 2 phones. They all have, sensors for light, for sound, and even the camera itself is a sensor. It just happens to have multiple things there, and how that's basically recombobulated and built into an image, built into sound, and then transmitted. That's instrumentation. We're instrumenting this environment where I'm actually giving this talk. But the idea is that it provides a window in on this process. So, as a camera would provide a, input into me speaking, getting sensors enabled into your environment is a way to get a view in. One of the things, as I mentioned before, that Splunk's really big into is application performance management. That's a big, hip new thing now. To understand, when you have to expand your infrastructure or build in some more resiliency to your application, that's where the next thing is. But for security people, part of the CIA triad is, that availability, the integrity, and the confidentiality. Some of those things actually tie into that as well. So you usually do this through, you do your system profiling, understanding your CPU usage, other resource usage, and so forth, and understanding what's triggering all of that. The extra level of that is getting to that granularity. It's great. You may get a log file. It may make sense. It may not be making sense to you. It's maybe not exactly human readable. It's just machine data. There's a lot of tools out there that'll help you kind of make sense of that, compare it to other streams of data you have going in there. And that's the importance of instrumentation. So sampling, on the other hand, is getting that population. So you typically can't extrapolate the status of your environment from one computer or even one network device. Typically, you want to sample it from a bunch of different devices and a bunch of different computers from different places on your network. So that's the key part of sampling. You think of this right now as in the year 2020. It's our decennial census here in the United States, and they want to count all. That's sampling everybody. That's getting data from the entire population. For that, it's very precise. You get that by counting everything. In other terms, you do sampling, where you're inferring based upon a smaller sample of population. There's certain characteristics behind it. And with that, you can basically make inferences about the status of that population, whether it's rich or poor, it's living in certain conditions, the food availability, and so forth. So that's the advantage of creating those populations and creating those samples to allow you to actually get a better extrapolation about the status of an environment. So instrumentation is the poking in of that environment using those tools, and the sampling is actually building out that population. Now, as I mentioned before, census, that's rote counting. That's trying to count every head in the shed. Sampling, as it is, as I mentioned before, is a smaller part of that. And with that, it saves you time, it saves you effort, saves you resources, and that's actually where the benefit comes from that. So next, as I can do the screen here. So, I come from the world now of DevOps. Prior to Splunk, I was the chief technology officer for a government agency, and that was generally new for me. I came primarily from the security world, so now I had to kind of consider a lot of that. So, in that world, in development world, the main instrumentation examples are profiling, counters, and logging. Logging, every security person knows. That's basically, you send me that huge pipe of stuff. It has all the data all the time. I mentioned too, application performance management. Those are counters. You're incrementing or decrementing counters of the status of a stack or the status of a system or an application. You can get down to the lower level. This is actually, you want to get into some real deep hardware stuff. You're looking at the stacks within your CPU, understanding what things get triggered, how the architecture, the low-level hardware architecture goes. That's where the counters kind of get into that. Your profiling is more or less your surface analysis. That's your more kind of lightweight stuff. You're getting a general surface view of things. Typically, from the security world, you're doing either static or runtime analysis. That's a form of profiling. And with that, you can glean a certain amount of data before you have to kind of dig in, but it gives you a very quick way to get an idea what the status is on the system. Now, as examples, there's probability sampling and non-probability sampling. I don't want to go too deep into this because that gets into a whole level of statistics that will require an entire other talk. But, a lot of these types of sampling get you different things based on how you structure that population, how you structure what you're looking at, and the amount that you're looking at that. So generally within the probability sampling, it's much more along the lines of random. You're just kind of peeking in the status of the thing. You have no idea. There's no known static state of that. You're seeing it as it goes across the wire. It's typically, the probability sampling is literally you're sticking your finger in the river at the time that you're next to the river and basically pulling up what's available there. The non-probability sampling is you're very well defining the time, the place, the state of where it is, and you're sampling from that state and time, and that's where you're extrapolating your inferences from there. So next, the cases for those probabilistic sampling, there we go, is the reduction of bias. And how does that actually apply to security? Typically, when I worked for large organizations, the bias comes from, if the security organization works for the IT organization, it reports up through the CIO or the CTO, and goes up to the board that way. It's a little bit of the fox guarding the hen house. If the CIO tends to know what the CISO or the security team is doing, they can basically start to bias what they're particularly sending to the security sensors. The idea of random audits, or the ability to kind of pick and choose where you're actually pulling your data from on a basis that's non-deterministic. It gives you a chance to get a more realistic picture of what's going on in your environment. And for security people, we talk about I forgot the term for it, but they're basically alert fatigue. You can kind of create that because if you're sampling the same thing all the time and it's this known quantity that's going across, that is whatever was shunted to you, it's just going to get boring, and it's not going to provide any useful data for you to draw any inferences from and actually act upon. The other advantage with the probability sampling is the software quality control. You can kind of think of like Laverne and Shirley, the opening to that, where there's the bottling line and they just pull stuff off of that at random. That's probability sampling. You're just pulling a random bottle off of an assembly line. It's greater for quality control because no one can basically determine that they're gonna pull that bottle, unless somehow it says please take this bottle. There's a sign that says please take this bottle. The process testing too is another one of those cases of when I was the CTO there. Part of our modernization activities were basically looking at processes without technology. Basically, let's think about what you're starting with, what you're going to end with, and actually sample what that process means. Do you have too many steps in there? Is it stuff that doesn't need to be in there, that's legacy? And that potentially on the security side of things allows you to remove cases for error or problems that may arise or errors that may be generated by the user or the system. There may be old components in there that are causing, say, something flapping at a sensor because it's being fed bad data from an old process. And typically, too, security side of the house likes the black box testing. Let's kind of throw something at this, environment here and see how it reacts. It's almost a little, I wouldn't say necessarily Schrodinger's type kind of thing, but it's more along those lines of, you don't know about it until you look into it. It's no longer kind of a black box. You got your inputs, you got your outputs, and it's an unknown value there. So, those are the kind of types of sampling there. So for non-probabilistic sampling, if I can get this slide to move over. Oh, there we go. Went too far. As I mentioned, that's much more, towards modern IT systems. The metering systems. You're looking at how much bandwidth is being consumed. That's you're looking specifically at that pipe. You're looking for a certain type of data. You know that you're looking for HTTP requests or certain calls to a database or whatever. Anytime it's outside that expected response, say you get a HTTP response or a flood of traffic that is considered abnormal, out of that's one of those cases where it's off the norm. That's you, as I mentioned before. There's a low likelihood of that changing over time unless something is awry. So there's your sampling for that. Then it's as you have the picture over here is a kind of the convenience sample. With that is you are using that to get finer and finer detail on an environment that you have well defined. Say you have a series of VM images or a couple boxes you've imaged the same way. And all you have is you're metering on the outside and you check and you see something flipping, but you know there's 8 boxes potentially. They're all imaged the same, but every 10th piece of data that comes across there is not what you expect. Knowing Windows, very noisy protocol and whatnot, something could be configured. It could have, someone could have fat fingered. And with that is, you're trying to refine the quality of a population based on, that data that you know about the population, that it's a Windows box, that there's 8 of them, that they are within this VLAN, that you are looking at this data. So for that, on security stuff, that knows what your exceptions are. So there are best and worst practices when we talk about sampling. Worst practices are essentially don't instrument, don't sample. It's out of sight, out of mind. If something happens, not my problem. We know a couple of people will behave like that, but we won't mention them here. Best practices are you're looking at things. Now with the COVID-19 stuff, we're sampling. That the whole thing about doing the testing is you're doing sampling. Instrumentation are the different types of tests that we're doing. So those are considered best practices. So in the security world, the same thing is if you're not monitoring your network, you're not checking logs from, say, antivirus or your firewall or whatever other security tools you may have on there, your proxy logs, you don't know what's going on. So your goals for instrumentation and sampling, you're trying to maximize productivity. You're optimizing for that. So you're trying to basically make sure that it's the shortest path from point A to point B. Part of that process stuff is knowing that instead of going the long way around, unless you like to see the scenery, you want to get there in the shortest time possible, the least amount of hops and least amount of effort. It's the lazy person's guide to managing technology. Stability. I know some of us really love our jobs, but if there's a way to kind of not so much automate ourselves out of a job, but do it in such a fashion that we're not creating busy work by responding to alerts, doing break fix and so forth. It gives us more time to do the things that we really want to do, kind of the cool stuff, to go and create or go and investigate or sometimes just kick back, put your feet on the desk and enjoy the fact that you've done your job because you're not responding to alerts. Reliability, you're getting paid to build systems that you can trust, and not just trust that they're built securely, but they're trust that they work. One of the things we've seen from this COVID-19 stuff is that the supply chain is not as reliable as we think it is. Toilet paper goes missing. The food supply, wanes and waxes every so often. Even getting Instacart. Knowing that we've tapped out that supply in some places. Getting stuff delivered. Those are the reliability aspect of that's gone. Again, too, is safety. You're wanting to make sure that if you're looking at say I mentioned kind of doing the random samples, you're checking that the fire extinguishers are not only there but they work. You're making sure that your web proxies or your web application firewalls are actually blocking the stuff that you have it configured to block. That's some level of safety. And then too is continuity. Especially with processes, having done many COOP and DR plans, is that that's an unbroken cycle. You don't survive very well if, as part of, building out and architecting your environment, that, you go through step A, step B, step C, all the way down to step Y, and then suddenly there's a gap in step Z. Was that known? Was it an unknown? But doing that instrumentation of that entire process, sampling it randomly, putting test data through and ensuring that it actually completes, that's a way to help build in security in your environment. So those all have mentions there. Your productivity, you want to do as much stuff you can do in one day and go home and feel like you've had a good full day's work. Obviously the stack of cards. I list Toyota as reliable. I've never owned a Toyota. I'm sure there's a couple people out there that can swear by Toyotas, but I know they get a name for being extremely reliable. On the other hand, Volvo cars are typically seen of as tanks, so I would consider that as safety if you want to kind of compare the two. And then, as I mentioned before about continuity, as we're seeing now with the current pandemic stuff, is ensuring that when someone gets sick, they can go to the hospital, they can get well, and they go home. That's kind of a continuity, and we're sampling that. Those are all the dashboards that are being put out by the states, by the World Health Organization, and so forth. That's that level of continuity that we're tracking. That we're using that data to actually drive decision making, to understand where we are in this process. So as I mentioned too, it's a river metaphor. It's easily viewable by people. You can walk down on the riverbank, you see water going by. There could be trees, there could be sand, could be some person sitting back having a barbecue. But, generally, you kind of think of your IT environment as a river. Your network runs through it, your trees, your land and stuff, you could potentially be your cloud environment or your on-prem environment, or, it could be an entire virtual environment that's everything's just done, with mobile devices and so forth. So with that, let's see, get to the next one here. Mentioned network is a river, water is the data on the network. So with that is, what do you instrument? Where do you instrument? What are the devices and methods are you using? Or are you only worried about flow, the content, type of traffic, or something else? Where do you instrument? There's many touch points on the river, as well as the breadth and length. So if you got a wide river, you got a narrow river, you have a short little creek, little tributary or whatever, as you with the network with branches and stuff like that, you kind of have that same parallel there. Where do you place those instruments to get the best data? It's very easy to basically say, I'm going to put all this instrumentation on the big pipe and just make sure I just catch everything in and out of the big pipe. But, instrumenting on those network segments is also useful, mainly because you get an idea of what actually adds to the bigger part of the river. So you're instrumenting your tributaries, your creeks, and so forth. The idea too is, would things change if you dipped your, finger or your instrument that you're instrumenting that river in the center of the flow or near the edge? It's more turbulent near the edge. That's kind of like, as it starts to run into stuff, that friction there, it's a different environment at the river's edge than it is in the center of the river. Same thing goes for your network. If you're just looking at, say encrypted traffic, that's a big pipe some people just tend to ignore. It just runs down the middle and goes out and does whatever. So they just look for the unencrypted traffic. That's basically, what are you instrumenting for? And then what do you sample? Is it a trust but verify situation? As much as you would love to have all the tools, all the bandwidth, all the time in the world to look at everything, it becomes expensive. It becomes more complex. So, what do you do to provide the best corpus of data to help you make decisions? and draw conclusions from what's going to support your business decision, what's going to support your actions as a security professional to act on reacting to an environment or an event or a situation. And the other big thing is, what conclusions can you draw from this? The biggest challenge right now is the whole correlation does not equal causation. That's a fallacy we kind of tend to run very hard here in the security world, because we get one security tool to do X, Y, and Z, say vulnerability scanning. We'll run the scan and say, yeah, your system's vulnerable, but no one's say running a different tool or using data from somewhere else to ensure that as that vulnerability tool tickled that machine or that box or that application, that it's actually producing valid results. So a lot of times you want to do the trust but verify, but you need that data to basically see if that's actually something that's providing you truthful data or not truthful data. So then too, what conclusions can you draw? You want to think that one big shot, you get it all. That you're properly instrumenting everything from the get-go, and you just sit there happy because your sim console is pumping you pretty graphs and giving you colors and all sorts of stuff. But you get a new employee on, unless they're enrolled in some of the tools that collect the data. That's something that's hidden, that's out of the environment. So you could be missing that. So you always want to go and kind of check to make sure that periodically, or either through a well-built process, that new data from new sources that are being added to your environment are actually being collected by the tools that you have out there to instrument the environment. Eventually, you could be part of an organization that went from a startup to a large enterprise through an acquisition or whatever. I know Malware Jake gave a talk on this at B-Sides Nova about that, specifically like M&As, that due diligence, that say the acquiring company isn't as instrumented the same way, say, a startup is. Maybe they were really good about it, or vice versa. So you want to get and address those gaps and so forth. So too is what's detected. You're going to be drinking from this fire hose. Are you wanting to drink from the fire hose? Do you want to drink from a smaller garden hose? Do you really need all that data all at once? I know a lot of network engineers and infrastructure folks definitely don't want to just tail off in the network segment and basically give you everything. That's more stuff they've got to maintain. It's a chance to kind of make their own environment more unstable because they're having to mirror all that data over. So unless you build into it, you got to be very specific about what you want. So as I mentioned here too, is you have a polluter. That's your network traffic. That's your stuff that's down there on the river. This is easy stuff to grok. I mean, you talk about oil spills or chemical spills or whatever on the river, which is blatantly obvious. It's a magnitude. If it's a big oil slick, it's a big problem. If it's just a little trickle, someone dumped a can of oil in, or there's a machine or a pump that somehow has had a leaky seal, different levels of magnitude. Do you know if it's bad stuff or good stuff? If it's warm water into a cold stream, that's sometimes by design. I know power plants, when I worked for a power company, part of their system was actually running cooling pipes out into the lake to cool it and bring it back in. But that changes the temperature of the water, but it doesn't change the temperature of all the lake. So that's understandable versus, you have something that's not supposed to be there. And that's where you're basically looking at what you're trying to sample. So then too, where do you want to sample from? Do you want just the stuff that's downstream? So you want to stick something in the river or on the network that's downstream from the traffic generator or from the oil spill? Or do you want to also instrument further upstream to know kind of what potentially is good or what the clear stream is, so you can do a comparative analysis to know the difference from that being added to it? That's very important as you're starting to make those decisions, because a little trickle, maybe not that bad. It gets diffused in the flow. But if it's a lot, or it's potentially hazardous, it's bad data going across the network. It's you have a bad actor on your network. It's good to have something to kind of compare it against. Also too is do you want to look at this, not just the river, but you want to look at the land? As you notice, some of these plants here throw stuff up in the air. It's trying to get rid of all the stuff into other environments. It could just not just be on that network segment. It could be on another network segment, say your DMZ, or pumping stuff out over wireless, or something that's on the LAN that's just affecting the local area versus the rest of the network. So, knowing where you're instrumenting, getting data from there to help support better decisions. So, moving on here, just I want to kind of clear this up a little bit. So with the instrumentation is more on the idea of concept of network flow. It's kind of a beaver in the putting a dam in the river here. You can use that same paradigm of where you're instrumenting to kind of detect the changes in flow. Is your web application firewall actually preventing the stuff that it's supposed to be preventing? Is the policy device, your firewall, your traffic shaper doing what it's supposed to be doing? Is there a QoS drop over time? This is where ensuring when you're instrumenting for the data you're looking for, you're looking at something that you're basically trying to design your instrumentation around a query. You want to know if it's going to do X, if I give it an input Y. So it's very important to do that. And for security people, it's one of those cases you want to know if your tools are effective, or if you're one telling them that you've got to put this policy in here to protect an application or to segment off a portion of the network. Say you have a forensics lab that's not supposed to be accessible from the rest of the network. You want to make sure that that segmentation is working. So you want to sample there and make sure there's no errant traffic from elsewhere in your environment, or potentially a bad actor trying to get there. This could be active measures. You can have active sampling that will, if you look at say like I wouldn't say a wind tunnel, but basically wind tunnel has it, but the laminar flow models too, where they'll put a little bit of dye in there to watch how it behaves in that environment. That's one of those cases of an active sensor. You're dripping the data in there and making sure that as it passes through these other things, you're seeing what you're supposed to be seeing. It's that trust but verify model. So hold on a moment here. I'm unfortunately needed to scroll here, the idea is too here with instrumentation, as I mentioned, we're a company now that's getting into application performance monitoring. And you look at this from the security side of the standpoint, you're doing your instrumentation, you're looking at traces, you're looking at malware, basically how it behaves, where at the microcode level, as it jumps through functions. IDA Pro is a really good tool for actually instrumenting at that micro level. The macro level, we see network devices. The micro level is at the application performance management layer. Developers are doing that same thing. They want to know that is this an efficient function that they're implementing, or is this function actually too heavy for the activity you want it? You want to simplify it using tools like that and instrumenting it properly to kind of apply the stimulus, see the process and pull that out. Again, not just useful for app dev folks, but also useful to security people, because if they implement a poorly written function, degradation performance is actually a security concern, or implementation of a poor way of doing things. You've introduced that level of vulnerability. So getting that level of monitoring, that sampling, and instrumentation is important not only for the dev and the ops side, but obviously for the security people. So again, I mentioned before that security people are really good for I want logs of everything. I love logs, to be honest. It's almost an unbiased standpoint, as long as you can log, capture, and retain in a non-reputable format. It's always something you go back for. This is kind of like with voting. You want to have the paper ballots. And this gives you a chance to basically, let's go back to the tape. And logging is very much so. And the thing I just actually talked about before this talk, a prior talk on moving a part of our sector, part of our economic sectors to DevOps and DevSecOps is inertia. Traditionally, in environments like that, it's you're overcoming the idea of people wanting to not do something because they perceive it's too risky. It's a risk-averse environment, but they're also worried about, like, if we go down this road, how do we measure that change? If I need to go from 0 to 100 to count this as a success. Well, of course, obviously, but to go and do a lot of that time, you end up having to kind of get from 0 to 1. It's kind of that Newton's first law of motion there. There's an object that's at rest tends to want to stay at rest. There's a lot of effort and a lot of work needing to be done just to move that boulder, to overcome that inertia. And its key thing is here with instrumentation is knowing, I'm gonna, stick a ruler here. That's your instrument. I'm gonna, I move this big rock from 0 to half an inch. Well, if it required a lot of effort to do that, that's still a good thing because you're getting to start rolling. And that instrument's going to start noting that you're moving faster and faster and faster, even on flat ground, because it's a lot easier to move. Specifically on the side of data and analytics and metrics, there is also understanding that it's not just quantitative. It's easy to just basically count things. As I mentioned before, counters, like 1, 2, 3, I'm incrementing, I'm decrementing. Very simple thing. Those are kind of like vanity metrics. It's easy to say I went and installed 100 versions of Windows 10 in this environment, I'm done. But how long did it take? Did the users actually appreciate getting upgraded to Windows 10? Was it a better experience? Those are the qualitative measures that is required. And instrumentation for that is creating surveys. Those are customer service surveys. Was this useful? Did this help? Typically we have a lot of stuff we see on commercials where there's a telecom company and another telecom company that will knock each other on the reliability of their network or whatever version network, 4G, 5G, 6G, whatever they want to call the stuff that's causing all the viruses and stuff, as they joke about. They could be pushing 5 nines. Their network's up all the time. And they can claim it, they can measure it. They've got their instrumentation with their stats and stuff saying, our network was literally up. Like there was power running across it, there was packets going across it, and it was up. Even if it was one crappy packet with a massive amount of delay, it was up. On the other hand, when we're here at home dealing with this pandemic, the quality of that has gone down. I know over in Europe, I guess they throttled Netflix. That's a qualitative measure. That's people's perception of the operation of a 5.9 network or a 6.9 network. Is it may be up, but it's not producing a level of quality there. So as part of security people methodology is that's an availability query. It's up, but is it up well? Is it producing joy in a way? A little Marie Kondo type kind of thing. Marie Kondo your network, but developing those instruments, those surveys, helps you get other data points that aren't traditionally found just by instrumenting things. The idea too is say you're doing a phishing campaign, and you can send out 100 emails and get 100 responses back, and everyone caught all of them. But if it was an easy catch, if the end user is like, yeah, I know this is phishing because it was a poorly designed phishing attempt. That's a qualitative measure, and you need to go and survey that. Like have a town hall and say, did you detect that? And everyone says, yeah, you suck at it, and that's kind of a qualitative measure. So with that, you want to ensure that you're taking both sides there, and that belies itself in the instrumentation. So. My dad, as I mentioned, was a water quality chemist, and the wrap up here with the river metaphor, it's very easy to basically say that river's healthy, it's got water in it, it's flowing and so forth, but if the environment around it is sick, if you're not looking at that, if you're looking at seepage from agriculture or the types of wildlife that may or may not be in it, those are also indicators of health. Things you may not get, so you may have to look at different ways of counting things. You may have to look at different ways of observing things, and that's usually a lot of times up for security people to also think about is the non-traditional ways of looking at an environment. One of those cases is too sometimes specifically here in DC, we have the tidal basin. We have a freshwater river, but we are subject to saltwater tides. From the Chesapeake and so forth. So the composition of that area changes over time. It could be primarily fresh water one part of the day as the river kind of takes over the flow, but during the higher tides, it pushes back and more of that brackish water that is then made up of salt and fresh water kind of comes back in. You'll see those types of changes, and is that healthy? Or if the tides get higher, does that affect the environment further upstream? Learning to sample an instrument there, that way you have an ability to almost predict when things are going to fail. As I mentioned too, application performance monitoring, that predictive capability. Sometimes the security is going to be the first tickle. Sometimes it may be an application or something else in an environment in the cloud that may be flipping back and forth that may foretell a potential security incident. So working with teams like that is also extremely important. Finally, as I mentioned here, don't get caught sampling the wrong things. Understand your data. Like, if you're collecting data and you don't know what it means to you, you're probably collecting the wrong data, or you need someone else on your team to help you interpret it. If you've been told to collect this and it doesn't make any heads or tails of it, it's good to go and actually ask those questions as to why it's, what questions you're trying to answer by collecting this data. Make sure it's of high quality and meaningful too. With certain logging, you're going to end up potentially collecting very verbose logs, or you could have very brief logs. Sometimes brief logs don't have as much data in there, but you are logging. So do you want to turn on verbose logging? It gives you more detail, but you may want to tune that back after you've gotten to the point where certain fields may not provide you with the kind of data that actually is actionable. So that's one of the things about getting high quality data, is understanding what's in the data and how to tune it and use that to help make decisions. The key thing is too here, and I come from somebody who likes to work with data. Anybody who watched my Twitter account recently, I was complaining about the quality of data for tracking the pandemic recently. And it's because I like to look at data differently than say the next person down the street. For me, I went through Tableau's public website and was looking at different visualizations specifically on the pandemic data. And I stumbled across somebody in Pennsylvania who had a very good visualization of how I wanted to view the data. But you look across all the dashboards and there's hundreds of different ways that people are looking essentially the same data fields. So data visualization is personal. So if you could go and create a dashboard for yourself or for your manager or your peers or whatever within a SOC environment, you'll let them kind of work with the data the way they want to. They may get different inferences by comparing against different data sources. They may have a different way they look at it, kind of perceive what it means to them. Not everybody's an expert in everything, so somebody who is traditionally doing blue team may look at something different than a red team person or a purple team person, or somebody who is traditionally doing forensics may want more data or a different type of data than somebody who's just doing regular network defense. So understanding that you may be collecting it, you look at it differently, and understand that you have to work with those teams in order to make sure that you're helping everybody in that regards. And also, when you're basically instrumenting and pulling that data, you want complementary data, so that's a trust but verify. So see if you can find another tool. If you have a tool that's collecting QoS stuff, flow tools for QoS, see if there's a behavioral component that could help you do some insider threat stuff. But also get some reinforcing data there too. If you're going to go and strictly look at what Windows logins can provide you, the Windows application log, well, maybe you also want to get the application log from the application and see if there's any correlating data in there to give you richer idea. Also confirm whether or not if it correlates that both the Windows application log and the application's application log are providing the same type of errors or behavior or event logging. That helps you make a decision whether or not it's behaving in a fashion or something may be awry. I know, traditionally a lot of security folks will find out something that, especially when you're looking at forensics and logs, missing time. An attacker may have gone in and erased certain logs, but maybe they didn't know about a different place where things were getting collected. So using that reinforcing collection capability, but also complementary data from somewhere else that attacker may not actually look at. And finally, before we get to the outcomes and takeaways, is sampling. You got to choose wisely. Don't grab stuff just because it's there. Be aware of the event burnout and noise. The slow and low attacker. You have a IDS or IPS or whatever network monitoring system you have, firing off all these data, and you're just like, oh, this is here. but all the really cool stuff, the single fire events, may be below. So make sure you're tuning that, but also looking at some of those small bits of noise. There's different types of noise, but to understand where and what you're looking at. Again, correlation does not equal causation. Just get that through your head. Just because you can find two things that make sense doesn't mean that's actually what caused it. I can't say that's strong enough, just coming from a statistics background. The signals that you get, the logging, whatever, they're clear, they're strong, they're relevant. If they're not, discard them. If they're not providing the stuff, there's no reason to collect them. If they're not high quality, it's not high quality data, and it's not helping you. Granted, always check with the infrastructure and operations and application people. There may be a reason why it's there, but unless it's helping you with your job, feel free to question that. Beware of false positives. I can say about that is you can get lulled into a sense of complacency because it says it's there. It's in the log. Well, it could have been poorly written. There could have been a problem. So again, getting complementary data, different data sources helps erase those false positives. And just because you have a lab environment behaving and modeled the same way as your enterprise environment, it doesn't translate over well. So if you're going to go and sample stuff, if you build up a model in a lab before you deploy it enterprise-wide or whatever, test it in the enterprise, help verify your design. That's the whole reason you do pilot projects and so forth. So, it may not scale either. It may get to the point where you're developing a sampling methodology or a capability or a data collection capability that once you turn the fire hose on it, it's going to behave a lot differently than it did in your lab. So use that to help draw informed conclusions and support better decisions. And finally, your outcomes and takeaways. Move one more here. Instrument with intent, sample with meaning. Select where and how you instrument to get the most meaningful data samples. Multiple places along that stream, not just the one spot, even though it may be cheap and simple and easy to do. We've built network intrusion detection sensors that sit on the inside and the outside of a firewall. One gets popped potentially, or one fails, you still have a backup. You also see what happens when it traverses stuff. That's the advantage of different instrumentation modeling. Sample with meaning. Someone goes and tells you to go look at something. Ask why. Make sure it's going to support a decision. If it doesn't support a decision, there's sometimes no reason to kind of go and do that. Find the populations you're looking at. Don't say, I want to count how many birds there are in the pond, and then only look at what birds are sitting there on the land because it's too difficult to look at the lake. That's a really bad analogy or metaphor. But, make sure when you're sampling the stuff, you're bringing in, what you've been asked to kind of go and do and help support that initial question. This is some pushback from me to my employer. We're really big on automation, but humans are really good at pattern recognition, really good at making better informed decisions. So I'm not a big proponent of AI right now because it can get poisoned. I consider AI as assisted intelligence. It can kind of help you go in the right direction, doesn't necessarily erase decisions. So be careful of folks who say, we'll just throw all this data at this and it'll go and chew on it and give you this thing. I know my previous employer was willing to do an AI pilot on something. And I said, well, you can do that on this new data, but as long as it's you've got results from the previous model, check it to make sure that it's drawing similar inferences. It may develop new ones, but make sure it's also developing similar inferences or known inferences. In fact, run it on the old data to make sure it's kind of generating the same stuff. So be wary of folks that say that they can automate your problems away. Always check with previous experience and previous data and previous models. Having more eyes on it is always good. I'm sure folks who've done development who really kind of care about delivering and architecting systems in a right way always appreciate having another set of eyes on it. I know we're in IT and security specifically driven by a lot of ego. We think our crap doesn't stink. But it's also good to have a second check. And I know folks who tend to go to a lot of conferences, that's a good chance to do some validation. So that's always a benefit there of opening yourself up to criticism and having another set of eyes look at something. And finally here, you are what you consume. Data is only good as if it basically helps provide some insight. If you're collecting data for the sake of collecting data and not getting a picture of your environment, maybe you shouldn't be doing this right now. But I think everybody can benefit from proper data collection of their environment and instrumentation. It can help justify budgets. It can justify additional resources of staffing, stuff security people traditionally always are fighting for or trying to justify why they're there and why they need X, Y, Z for these tools. Data quality is important, as an important paramount. Ensure that it's high quality data. I can't say this enough. In fact, sometimes you get in certain environments, you need data storage. You need somebody who's going to go and manage data formats, data libraries, indexes, and so forth, ensuring that it conforms to certain formats. And when it goes off those, that basically says you have a data quality issue. And in large environments, it gets to be that. But if you're a startup or a new company, you can implement that now. Just make sure that it'll scale, and that helps you use and trust your data in a fashion that'll help you grow. And again, too, more is not always better. I love the fire hose as much as the next person, but I also would just love to look at the data from my electronic litter box I have over there. I'm recording this in the basement, but just to understand, like, how does the damn thing work? Having to sort through and find the needle in the haystack out of a fire hose is not fun. It's time consuming. Takes up a lot of query time and so forth. So, one of those cases where, sometimes a trickle is better than the dam releasing all of its stuff out of the spillway. So with that, I thank you for your time. I thank Scott. I thank everybody here who's tuned in, and take care.
Man, that is a lot of information. That's a lot of information. I got an echo on your end.
Oh, sorry.
No, it's
okay.
I turned down the volume.
It's all right. So, it's funny that you would bring up the Last Crusade as a reference, especially for going down the stream. Like, so many Indiana Jones movies can actually be referenced in metaphor to what's going on as people are entering the workplace. Like, are they running from the boulder, right, in the Temple of Doom,
Right.
or are they trying to find the Holy Grail of data, right? Like, it's
or it's that the bridge crossing there in Temple of Doom. He's not mad. He's crazy. Yeah, it's choose your path wisely always. But yeah.
that's our interns. They're short rounds.
Yeah.
Oh my. No, thank you for coming and talking about this. A lot of people have a really hard time with trying to figure out where to start with log collection and getting that stream. Where would you point them?
There's plenty of really great resources out on the web that I don't have anything off the top of my head, but there's a couple of the SANS papers that have been written by the students for some of the G level stuff that as folk, and most of the I found most of the papers there are experiential, like they have an environment they exist in and this is what they did for their paper. I learned trial by fire for myself. It was to a point where I walked into a Fortune 125 company, and we had no log capture, and I had to go around to our network team. I had to go around to our Windows Server team. I had to go around to our Unix team, and ask them, are they collecting data? Are they collecting logs? Where are you sending them to? And can I have them? And a lot of times with that is it's also politics. I think there's plenty of technical papers out there. I mean, every product, every competitor to us has implementation guides, which tells you how to hook up everything. So there's no problem there. I guess the one thing I would say that really no one's really kind of written papers on is kind of the dance of the politics for that. Knowing how to ask for the right stuff. We're still very well siloed in IT, I think. to the point where, Windows person, is slowly working their way off the on-prem servers or doing desktop maintenance to understanding they're going to be doing, virtual desktops or servers and maintaining that environment. And they're going to need some help from different schools. So you do a little bit of trading with them. It's like, well, I'll teach you how to do cloud. If you are willing to send me some logs or, willing to kind of work with me on this, I'll help you because, a lot of the folks who are doing cloud implementations, there's some really cool tools out there that do that. You just basically point stuff at it and it takes all this off of them. It does the correlations and stuff like that. Really super cool. So that's understanding the kind of the art of the deal, the massaging that's needed to kind of get those processes in place.
Well, it's especially interesting that we would be talking about this now because we're noticing a lot of compliance regimes starting to pick up logs, like CMMC in particular. If you want to be a CMMC level 5, not only do you have to collect logs, but you also have to verify that the logs are correct and then be able to audit those logs and show that they haven't been touched.
Yeah, I actually had those in some notes. I couldn't get scrolled down, but I think I also talked about this on as I made an allusion to a talk I gave this past Friday, where the audit capability is incredibly important. There's some places that are highly regulated that require this, or when I first started doing a lot more on the security engineering side, we were just starting down the road with SOX, the Sarbanes-Oxley Act, and we would have the compliance, the auditors kind of come in and they'd ask for something and we'd give them something and we'd be this back and forth to try to figure out like what's actually required to satisfy the compliance. To satisfy the retaining for a certain regulatory environment. I know. Especially in the public sector where I came from, there's some of the records acts that's required for, you maintain them in a certain fashion for a certain amount of time, and then they need to either be destroyed or sent off to the National Archives. In what format that they occur, where are they stored? I mean, for us, we're trying to get all digital so we don't have to send boxes of stuff. And basically, finding systems allow you to kind of account for all of that bookkeeping, essentially, as it comes down to it. You're doing digital bookkeeping.
Now, as we're giving these presentations, because let's face it, we give a lot of presentations, right? Normally during the presentation, there's a point where we're saying in our head, well, I forgot to say this. Is there anything that you forgot to say in your presentation that you want to get out?
No, other than I could use a good stiff drink right now because my throat's killing me. So, yeah, no, honestly, if anybody ever wants to reach out, I love this topic. I'm still getting into this, mainly because the environments I've worked in have always been more. I've been a lot of these in the leadership and managerial roles, so I haven't had a chance to kind of solely define them. But for me, I also like to discuss new and novel ways of addressing this. Because not every. I think the key thing I did mention is everyone's environment is different. There's no cookie cutter. I've moved from agency to agency, company to company, different sizes from 11-person company all the way up to almost 200,000 people. Right. Everybody does it different ways. Some people are a little bit more clever and are efficient about it. But sometimes people find new tools or new techniques that someone hasn't thought of, and I'm looking for innovative stuff like that because I would definitely love to enrich this talk a little bit more. I used the river metaphor because I knew it from having to hang around rivers with my dad. But if there's other ways to mangle that, I'm totally appreciative of that. So.
Now, if people wanted to reach out to you on Twitter, how do they find you?
It's WebJedi, WebJedi, one of the nerdiest handles out there. So I'm on there quite frequently. So just send out the bat signal, and I will be more than willing to engage.
All right. Well, thank you for joining us. It's greatly appreciated for you to be able to take this time out and join us tonight. So, with that being said, let's do this wrap. Everybody, thank you for joining us tonight. April 23rd for the 4th episode of Who's Your Hacker? And hopefully we've been able to get you to think and be enlightened. Till the next episode, Scott Lyons for Amelie Koran. Have a good night.